Hi, I'm Sanola. I'm here to present our contribution as an S model analyzing and visualizing experimentation using RAVSim tool. In this presentation, we will cover the following topics: introduction, spiking neural networks, our simulator RAVSim tool, results, and conclusion. As many of researchers, they are trying to bridge the gap between neuroscience and machine learning using neuromorphic intelligence. A bunch of research already done on this topic, and thousands of research still required on this topic. That how human brain is able to solve a highly computation problem just consuming approximate 20 watts. At least human brain is still a mysterious black box for us. That how in neuron are exactly communication to each other. What exact neural architecture is implemented in our human brain. In general, we know that the human brain is good for efficient communication, fast computation, learning power, and multitasking, and so on also. And these are also the key point of neural network. And researcher community are still working on to improve our neural network. In previous, we have only a perceptron where it takes an input, applies weight, by and buys, and then produce an output using multiplication addition function. Then in mid of 1960, the researchers introduced a deep neural network based convolutional neural network, which are able to process more dimensions of input. Then researchers introduced a spiking neural network, and still research communities are trying to improve spiking neural networks, where we take spikes as an input, produce spikes as an output. Spiking neural network is fundamentally different from the conventional neural network in terms of parametric values and their dynamic behavior, as spiking neural networks are based dependent on a bunch of parameters, and their precise balancing of parametric values are required to gain an accurate output. The transmit data when their membrane potential reaches a threshold level. It's mean that here we are performing a filtration where we stop a useless data to moving toward the neural architecture, which in general we can think like in practical we can say that this functionality will save 50% of the computation cost. The utilize it utilize the concept of time in their execution. As bunch of spiking network tools already available in the SNN community, and they play a vital role to help the community to gain the accurate results. These tools have some limitation that, like, the current simulator for designing as a model is time consuming in both perspective, studying and understanding. As an early stage researcher, it took us a couple of months to understand how the basic flow of the spiking neural networks, and how the parametric values are dependent to each other, and which set of parametric value are required to achieve a correct output. As I already mentioned, that the parametric values, the spiking neural network model is dependent on those parametric values. And these tools are based on textual based programming languages, which mean that a user must be enough has a must be enough knowledge about the programming, aware, and also in these tools, a user need to run a lengthy code in each time, even a single updation. For example, in a set of parameter, if the user want to change a single parametric value, they need to run the whole bunch of source code. As SNS models require a precise balancing of parametric value. Model depend These models are also depend on those parameters as I mentioned, and these simulator are the domain specific language base. So to focus on all those problems, we come up with the solution of the runtime analysis and visualization simulator for SNN community. As the runtime simulator is required in the following sense: it allows the user to make direct change at any instant of time. It can be increase the speed of simulation. It will allow the user to visualize a graphical output for their analysis, help in designing, parametric tuning, visualizing, analyzing the model. A runtime simulator not only helps the SNN community to analyze and visualize the model, but also give the user to fully a user a friendly environment where users are able to understand a complex structured model. With this motivation, we introduce a RAVSim, a runtime simulator, a runtime analyzing and visualization simulator. As RAVSim is a standalone simulator which allows the user to interact with the model on a real-time environment. It is an interactive simulator environmental tool. It performs analysis in order to gain accurate parametric value, allow the user to interact with the model and observe the behavior of a model all during a runtime environment. It is basically a substitute for the time-consuming code-based experiments for analyzing and designing the spiking neural network model. We believe that it is fast, real-time visualization, also provide a user-friendly environment where users are able to gain an accurate parametric set of values in a friendly manner. The basic flow of the RAVSim, we use a link integration file model as an input, and then you can look at the big screen, the center screenshot where it is it's basically a real-time experimentation VI where users are able to play with the spiking neural network model by increasing and decreasing different parametric values. And on the left side of the graph, you can see a spike direction by using a continuous noisy input, and on the right side, neuron communication and spike direction by using input current. And users are also able to generate an external plot like mixed signal plot after completing whole simulation. They can look at in a big picture of the screen graph, and also VTN network with three different list of conditions. In this demonstration, you will see that how the RAVSim is how much the RAVSim is user friendly, where users are able to get an idea of the basic spiking neural network model in friendly and a faster way as compared to a text-based simulator. As you can see that the user are able to increase and decrease the parametric value. User can increase the simulation speed. User can decrease the simulation speed. On the left side, as you can see the spike detection by using the continuous noisy input. User can increase and decrease and can look at the results on the right side of the graph. User can see spike detection by using input current and the neuron communication. In case if user lost the set of parametric value where they are not able to get the exact results, user can also go to the menu and see the default parametric values. In RAVSim, a mixed signal external plot allow the user to visualize the spike detection using input current and spike detection by using continuous signal values together in one single graph. And it also allow the user to capture the graph for further documentation procedure. By clicking on the continuous simulation, users are able to move back to the runtime environment. And for the VTN network, user can visualize the neuron communication with three different list of conditions: I equal to J, I not equal to J, and fully connected network. For the output verification of the RAVSim, we compare the RAVSim output with the Brain2 simulator. Brain2 simulator is one of the famous simulator in SNL community. The things which make the difference of RAVSim and Brain2 simulator is that Brain2 simulator it required the starting point, starting time, and the whole simulation time, and at the start of the execution. For example, if user want to check the set of parametric value, let's say 60 second, the user has to provide the 60-second simulation time simulation time period at the start of execution, and then wait 60 seconds and then change the parametric value and then run again the whole bunch of the source code. But on the other end of the RAVSim, user are able to change the parametric value during the runtime simulation. Once the user achieve a balancing set of parametric value, user can leave immediately. And that's we believe that RAVSim play here a vital role. which is like Prime 2 is Prime 2 or other textual-based programming simulator are time consuming, and RAVSim can save a bunch of time to achieve accurate parametric values. The average time taken in VT analysis, we use six different set of neurons, where you can see that 100 to 500, and then we use 1000 neurons. It's mean that we tested a RAVSim simulator up to 1000 neurons in the three different list of conditions. As you can see on the list of condition I not equal to j, where the RAVSim is able to achieve the execution time approximate 12 millisecond with 1000 neuron, and the Brain 2 simulator is use around approximate 328 millisecond. Why? Because the I not equal to G is the most complicated list of condition we where this model need a lot of computation, and we can see a big difference at how much the RAVSim is faster as compared to the Brain 2 simulator. In conclusion, we can say that RAVSim is a standalone interactive simulator which allows the user to interact with the model, make direct change on the parametric value all during the simulation at any instant of time. For future work, implementing other SNN neuron and snap-based model and various learning techniques are still under consideration. And we believe that the further extended version of RAVSim is also beneficial for the arrested researchers and students, which allowed them to understand the complex structure of the neural model in faster and a user-friendly manners. Allowing direct change during designing a neural network on a hardware with a runtime simulator-based environment is also consideration. We believe that providing this extended version of RAVSim is also a standalone simulator which allow the user to interact the hardware during the runtime simulation. Using a runtime simulation, user can increase and decrease the parametric value. User can and verify a balancing set of parametric value and see the output. Uh, with this RAVSim simulator, our runtime analysis and visualization of SNN model will be an interesting area for further research, and we believe that it will be open more research area for the SNN communities. RAVSim publicly available on LabVIEW official website, and the user manual is also available on our GitHub repository. A video demonstration can be accessed on our YouTube channel. And beside this, if someone need more assistance, they can directly contact us via email, and the information can be found on the RAVSim menu bar help page. Thank you so much.